Hey everyone, and welcome to today's Explainer. Today, we are demystifying one of the absolute most transformative technologies of our entire generation, artificial intelligence. I know, there is a ton of noise and hype out there right now, so we're going to bypass all of that. We're going to trace AI's journey from those early academic theories right up to the modern tools we use every day, and break the whole thing down so you walk away with a really solid, grounded understanding. But to really understand where we are, we kind of have to start at the very beginning. Can machines think? That famous prompt was actually asked by Alan Turing way back in 1950, and it effectively launched the entire field of computer science and AI. He proposed a test to see if a machine could convincingly imitate human conversation. And honestly, it was a radical idea at the time, and it sparked this decades-long quest to replicate human cognition. Okay, let's dive into this. Here is our roadmap for today. We'll start by defining AI. Then we'll look at its evolutionary winters and explore the massive shift toward machine learning. After that, we'll categorize modern AI, examine some real-world applications, and finally, we'll take a peek into the future with AGI. All right, Section 1, Defining Artificial Intelligence. What exactly are we talking about here? Let's establish a working definition. Artificial intelligence, or AI, refers to computer systems designed to perform tasks that typically require human intelligence. We're talking about things like understanding language, recognizing patterns, and making decisions. Now, the absolute key takeaway here is that AI isn't magic, right? It's a highly practical set of technologies that rely on data, algorithms, and computing power to drive those everyday tools you probably have right on your smartphone. Moving on to Section 2, the evolution and winters, from high hopes to frozen funding. So, starting in the 1950s with Turing and the Dartmouth Conference, AI officially got its name and, well, its early hype. But take a look at the 1970s and 1990s. These periods are known as AI winters. See, early researchers made incredibly ambitious claims, basically predicting human-level intelligence in just a few short years. But the reality? Early computers were just way too slow and ridiculously expensive. When those sky-high expectations outpaced the actual results, funding from governments and corporations just completely froze. It literally wasn't until the 2010s, with the deep learning boom fueled by massive amounts of internet data and a huge leap in computing power, that AI truly thawed out, eventually evolving into the generative AI era of the 2020s we see today. Which brings us to Section 3, the machine learning shift, learning from data, not rules. And this brilliantly illustrates the difference. On one side of the coin, we have symbolic AI, which is often called good old-fashioned AI, or GoFi for short. This approach relied on human programmers writing out explicit line-by-line logic and rules. And, it worked perfectly for highly structured things like chess, but it totally failed in messy, unpredictable real-world scenarios. But then, on the other side is machine learning, or subsymbolic AI. Instead of hand-coding every single rule, you just feed the system massive data sets, and it learns the patterns automatically. It's incredibly flexible and highly adaptable. To really see what this means in practice, think about recognizing a cat. If you're using old-school symbolic AI to identify a cat, a human programmer has to write rigid rules, like look for two pointy ears, whiskers, and a tail. But what if the cat is facing away or curled up in a little ball? Suddenly, the rules fail. But with machine learning, you don't write rules about pointy ears at all. Actually, scratch that. You don't write rules, period. You just feed the machine thousands and thousands of labeled photos of cats, and it discovers the visual patterns entirely on its own through trial and error. This shift to a data-driven approach is literally what makes modern AI so incredibly powerful. Okay, Section 4, categorizing modern AI, understanding the types and functions. When we break AI down by its actual capability, we end up with three main categories. First up is narrow AI, also known as weak AI, which performs specific, predefined tasks. Second is general AI, which would feature human-level reasoning across multiple, totally different domains. And third is superintelligent AI, which would just exceed human intelligence across the board. But what is really fascinating here is that everything we currently use today, absolutely everything, whether it's Siri, your Netflix recommendations, or a super advanced chatbot, is classified as narrow AI. It only operates within its predefined parameters. General and superintelligent AI, those are still strictly theoretical. We can also categorize AI by functionality. Reactive machines just respond to inputs without storing any memory. Think of IBM's Deep Blue playing chess. Then there are limited memory systems, which use past experiences to adapt and improve decisions, like self-driving cars. And finally, theory of mind, which is this future research phase concept where AI could actually understand human emotions. So the crucial point to remember is that almost all the modern AI tools you rely on today utilize the limited memory. By constantly ingesting new data and recalling past interactions, they continuously adapt and improve their output. Now, within these modern systems, we also see a big split between generative and predictive AI. Generative AI is all about creation. It's producing original text, audio, images, or even software code from a simple prompt. It literally gives you something totally new. Predictive AI, on the other hand, is all about forecasting. It analyzes historical data to project future sales trends, spot market anomalies, or even detect fraudulent banking transactions in real time. They are both subsets of machine learning, for sure, but they serve entirely different real-world business purposes. Let's look at Section 5, Real-World Applications. How AI is shaping our daily lives. AI's influence is just vast right now. In healthcare, it's out there predicting disease and personalizing treatments. In finance, it's managing massive risk portfolios and identifying fraud. In customer service, it's powering 24/7 personalized chatbots. And in entertainment, it's the invisible hand deciding what music or movies you might want to check out next. But consider transportation for a second. Autonomous vehicles rely heavily on that limited memory AI we just talked about. They have to ingest immediate data about road conditions and instantly cross-reference it with historical data to make split-second, literal, life-saving decisions on the road. The application of this technology is profoundly, fundamentally reshaping our society. Let's move to Section 6 and see how this builds into our final topic, the future, AGI and beyond. Where is this all heading? As we look forward, the absolute holy grail for many researchers is artificial general intelligence, or AGI. This is a proposed future system capable of performing a really broad range of tasks, utilizing human-like reasoning to learn, adapt, and improve autonomously across many different domains rather than just being stuck in one. Now, what separates today's amazing tools from true AGI essentially comes down to one single word: generality. Right now, a system like Deep Blue can beat a grandmaster world champion at chess, right? But it cannot even play a simple game of checkers. Modern algorithms actually closely resemble non-hominid biological life. Think about it like this. A beaver is incredibly competent at building a dam, and a bee is absolutely brilliant at building a hive. But a beaver cannot learn to build a hive, and a bee cannot build a dam. Today's AI lacks the unique general applicability that defines human intelligence. And because the leap from narrow AI to general or even superintelligent AI is so incredibly profound, researchers are heavily focused on the predictable self-modification problem. As this quote notes, contemplating the eventual challenge of superintelligence down the road can actually give us directional advice for present-day AI research. We absolutely have to ensure that as an AI iterates and improves itself over time, its goals remain predictable and, most importantly, safe. This is exactly why things like ethics, governance, and responsible development are completely dominating the conversation at top AI labs right now. Which leaves us with this incredibly important, lingering thought. As AI evolves from a passive tool that just sits there waiting for your prompt into an active, autonomous agent that pursues its own complex, multi-step plans, how will we design its goals to ensure they safely align with our own? Honestly, it is the most defining technological puzzle of our generation, and finding the answer will shape the entire future of society. Thank you so much for joining me on this explainer today. I really hope you walk away with a much clearer picture of how this incredible technology actually works. Keep learning, and I'll see you next time.
Thanks for watching SB Insights. Don't forget to like, share, and subscribe and updates on education, technology, and innovation.